Hello everyone, my name is Shu, and also I'm going to introduce this topic together with Xiao MiaoMiao. It's mainly some basic knowledge about Linux. And on our another speech of us, we have introduced KDEM, and also they have listened to us on KDEM, and they ask us, I don't understand KDEX. I'm working on Kubernetes and working on Docker, so I don't understand what do you talk about the KDEM. So today we would like to introduce something basic about kernel of Linux.
那我觉得从我笨出这个10几年有从事跟Linux 相关的一些工作。
And based on my 10 years of experience working on Linux, I think we should first consider several questions. Why we need an operation systems? When we are sending messages on our phones, we are listening to music at the same time, maybe looking at information about the stock markets. If we don't have any of the operation systems of the OS, then we know that there are different kind of processes. You need to switch between different process because it's not going to run at back end. And without these multitask operations, we are unable to work on many different things in this world. We know that OS is a manager, so as a manager or administrator, what kind of things you need to do? Also, what's the object of this OS? I think for the newbies of this field, you need to consider the following questions. Maybe you have learned about OS in your universities. Maybe you will recite some of the concepts about it or definitions of some terms. But have you ever think about what kind of content or what kind of objects that the OS is managing or administrating? When we get back to about half century ago when the computer was just born, and at that time the OS is developing together with the hardware, and what was the scientist doing at that time is thinking about. And after decades of development, as at first the Windows and also the Linux is very popular, and now the Kubernetes and also the other systems become popular. It would be quite helpful if you think from this perspective. Next, what's the relationship between Linux and Linux system and the Linux kernel? It may have some confusion between these two concepts. And also you can also consider what kind of design concepts that the Linux kernel can adopt. We know that there are different kinds of kernels, and for example, the Windows kernel, Apple's kernel, and also Google also has a V kernel of Google's, and also other companies will have their own kernels as well. So what is the design concepts of this kind of kernels, and what's the differences of them and the advantages of them? What is the overall structure of the Linux kernel? You can also consider from another perspective that what is interface between the kernel and the applications. We know that we have known about the interface between the kernel and the processors already. And you can also consider why the Linux kernels has been quite popular these years. Actually, the recent decade, for example, on our phone, we are running different type of the Red Hat, and also the different applications running on Linux, and even the fundamental framework of it is running on the Linux. And in recent years, originally it's a little bit cool in this industry, but because of the trade war between the two countries, and this topic has been popular again because we don't have a self-developed OS in China. If we design a new OS, what should we do? What is the most difficult things we should overcome? As a newbie, we don't think you should first jump into all of those codes of the kernels because it has about 20 million lines. We can first think about those questions we need to answer and to define our own directions in the future. First, I'm going to introduce the micro kernel and the macro kernel to you. And yesterday I have read post that it's a discussion between the Linux and the grep masters and talk about the Google's kernels and its difference with Linux. And I think the discussion between the micro and the macro kernels has been a hot topic recently.
So in the designing phase, there was some discussions and dispute against some university professors. So the micro and macro kernels, which one is superior? So this has something to do with the OS's function. So micro kernel. So for many of the independent modules of the OS, they use a message to communicate. But for macro kernels, all the modules were compiled into a binary system. So this discussion is still ongoing. I saw in many WeChat groups, people are discussing using micro or macro kernels. Before it's released, still there's a lot of guesswork involved and discussion involved. So this is like a compromise in design. For Linux, at the very start of the Linux design, engineers did not adopt the popular structure in the academia, which is a micro kernel. Instead, the designers used macro kernels instead. In 1996, Linux is like a graduate student's amateur product, and he prefers macro design with simple design and superior performance. But all the theories, they must be put into industrial practice, and that's how a compromise was achieved. And of course, a Linux kernel have fused with the advantages of both the micro and macro kernels. Linux kernel added a live patch functions that supports dynamic loading modules, including some of the advantages designed by engineer Shan. So let's take a look at the overview of Linux kernel. This is the overall architecture. It's divided into user space and internal space, because Linux adopted the macro kernel structure. So within the kernel space, they are a binary file system. We call it a image. But there are some drivers that can be programmed into modules, like for CentOS. It can automatically load the hardware drivers. And for some of the gate drivers, they can be dynamically loaded. And above it is our user space. And in the user space, you can see there is a very important layer called a system scheduling layer. So all the apps and programs, they will utilize the scheduler layer to visit the kernel resources. We know that actually that the scheduler controls the sessions. So it will provide accessibility of hardware resources for the programs and apps and sessions. And for the above user space, there are a lot of different forms of apps. There are native resources, native sessions. I use some of the C language session to access the hardware. But of course, Android system using Java is also popular approach. So using Java, but for some traditional stuff, including X window and Qt Bank and TT Bank, there's some graphic interfaces through Qt and GTK database, and then through libc, and then to the user space, to the system scheduler between user space and the kernel space. And of course, virtual VM is also quite popular. For VM, it can access the C language layer, but also Linux kernel, like a link space, etc. I will not go into details. Here is an overview of Linux architecture, an illustration of the scheduler. It supports different types of sessions, like session management, etc. I'm not going to details for the sake of time. And internal memory management is also a big component. Yesterday we talked about KCM, NUMA, and Barons. They are all related to internal memory, because internal memory management is a very complicated in different sessions. So this is, and also it includes the interruption management. And for Linux kernel, why it's so popular? It is because many vendors, they write the equipment drivers for Linux. And also Linux supports a wide portfolio of OS. And now I'd like to share the approach to Linux, how to learn Linux. And in Linux systems, how to do programming practices, like using the Olin kernels, using QEMU and CFS. I will not go into details about this part. I'd like to recommend 2 books. One is Linux 101. I will hand over the microphone to MiaoMiao to talk about the KUN architecture. Good morning. My name is Xiao Gorong. Now I'm in the open source team of Tencent Cloud. Just now, because of the topic is it's for beginners, so I will not go into details about what I'm going to talk about. And because of I was in a rush in preparing the slides, so if you have any questions, feel free to send emails to me or send your CV. Talking about a virtual machine, it cannot. We must talk about the types of hypervisor. We have type 1 hypervisor and type 2 hypervisor. And when KVM was just launched into the community, there was a wide discussion about which type it belongs to. For type 1, the definition, the hypervisor can directly control the hardware and then segregate the hardware resources in a secure manner and then distribute across VMs. But for type 2, the hypervisor uses traditional kernel interface to access the resources distributed for it and then redistributed to VM. So the 2 types hypervisor, the fundamental difference is that the hypervisor itself, is it bound on the hardware or on OS? So from this point of view, KVM belongs to the second type, to type 2, because it can access, before it accesses any resources, it must access the kernel interface first to enable management and isolation. In recent 2 years, there's a new approach called type 0. What does it mean? Its origin is quite brutal. Compared with type 1 and type 2, the GIF-AS, the hypervisor, the guest. So in type 0, the hypervisor is on the naked metal, is on the bare metal. So most of the cloud spaces, they offer bare metal services to better leverage the hardware resources, reaching 100% utilization rate. For Tencent Cloud, there are corresponding products. Here is the link for further information. I just mentioned KVM is a standard, using standard hypervisor. It's a list kernel module, and it offers interfaces for the user space management. And the management, this layer, will then manage the virtual machines from there. So specifically, KVM is in the generic versions, the default setup can be accessed from this file. And the user space can access the file to dock with KVM, and then to manage, like creating, suspending, or run simulations on VM. This chart for VM, its lifespan. So the future slides are about the lifespan of VM. I'll start from the boosting of VM. So it starts with the creation of VM. We can compare it as preparing the boxes. And with the box, you can inject some memories. You can register the memories. So it's comparable to injecting the memory to the machine. And after the registration, you can create corresponding BIOS and initiate the boosting environment. And then you can run vCPU, just like inserting the CPU to the server. And after that, you can run the VM and run the vCPM. In the process, because the CPU is shared between host and VM, so when it's running, when some of the access cannot satisfy it, it will be jumped back from VM to the host to complete the access and simulate the access. And when it's fixing the VM access, the VCM can jump back to VM to continue the commands. So this is during runtime. When one VM is completed its task, you can destroy the vCPU and release the memory and release the entire VM. So the next few slides is an analysis of the lifespan, how to create and terminate a VM. Just like I mentioned, it provides upper interfaces through a particular file, commanding file, and you only need to open the file and do outcome control. And the outcome control, the name is create KVM, create VM. And after the command, it will feed back the file description. And this description, you can understand it as a VM. And if you were to run the VM, you must operated from the file. And about the termination, the VNFD, you can close it, and then the VM module resources will be suspended. Memory is an important resource. You can see the registration and cancelling the interface.
First, let's look at the important structure in memory. You can consider it as the interlayer plugin. And in the first field is a slot. It's a matching with the number of the slot. And also there were some other text here. That is for the functions. For example, what is it writing or just reading only, read only, etc. And also you can map this to guess and which part of the guess, and you can specify the location of that. And after you have put it plug it into the slot, what is how big is this memory? And also we can utilize this structure to convert the location. And when it aligns with the KVM interface, you can use the memory region, the KVM user space memory region to register the memory into it. Because memory is very complicated, so I just demonstrate the visit route and also how the KVM to process it. When it's initialized, the memory is not allocated to anywhere, so there is no resources to it. When the memory access anything, then the CPU will switch from the memory to the host because of the trigger, and the hosts are going to check what kind of visit it is. Is it because there is no mapping of this memory, or is it because it's utilizing the access location? And it means the memory is trying to access the location of the guest and utilize it as the key, as the keywords to match with the slots in the slot structure. And later it's going to find the information needed. For example, the immediate location in the guest of this memory, and also the size of this memory, and also any other demand or query of this memory. After they have found the sequence number of it, they can utilize host interfaces to switch this sequence location to the physical location of this memory, and then to map this physical location to the VM, so that it's going to map and convert locations between the virtual one and the physical one. After they get access to the memory, if the memory is not registered, it means the user space do not match the physical location of this memory to register at the KVM, and then they will take it as an MMIO access. That is MMIO access. It means it's from the equipment. Then it's going to start equipment visit, equipment access. Then based on this understanding, they are going to try to match this location to the interface of the equipment instead. And next is the vCPU process. And there are two operations. One is creating, the other is deleting or destroying. And in VM, the CPU is used as the threads used on the host. So when the KVM creating the the CPU, then it's going to create this thread, and on this thread, then it's going to provide some interface and telling the KVM module to ask them to run the TCQU, and also to run the workload provided by the KVM. And the interface here is KVM create. And the interface for creating the vCPU is called KVM create vCPU. And later it's going to be back to it and close it. So you need to close and destroy the vCPU for the destroy operations. Running this vCPU is a very complicated process, but overall it has user space and also has the KVM module to go through the whole process. First, in the user base, you have established a vCPU and you want to run it, and you just schedule an interface for it to run it. And then it's going to get into the KVM module, and utilizing this module, then it's going to switch the running module of the running mode of the CPU. And if the vCPU get access to some of the sensitive resources for all equipments, they will get into a new mode that is back to the KVM module. So first of all, the KVM module is going to fix it themselves to satisfy this access themselves. If they found that KVM do not have sufficient resources to process it, then need some involvement from user space, then they are going to schedule some of the resources to down there, cascade some of the resources there, and then in the I/O control return and continue to run, so that it's going to have the exit state, and utilizing this state, it's going to support the exit of the KVM run. So first of all, it use the I/O control return and back to the return mode, and then do the mimic. And after that, it's going to schedule the KVM run again. And in the KVM module, it's going to use the space to send the command of the run. And then the KVM module is going to switch the KCPV. And after the workload is satisfied, it's going to exit the host. And then the KVM module is going to fix this problem itself. If they don't have sufficient resources, they're going to send this information signal to user space. Due to the constraint of time, this is what we can talk about. And now the Tencent Cloud is now trying to recruit some new engineers. And kernel training, including kernel training, Kubernetes. You're very welcome to join us. Any question? As for the threat that you mentioned just now, it's actually the process from the OS. You have the user space and use the piece writer to create. And then it's going to deliver this thread. So, and is it related to the CPU's thread of it? No, there's no relation with that. The OS, after you created the OS thread, is going to match with the physical thread. So even though whether you start the physical thread or not, it doesn't matter. Any other questions? I want to confirm for one thing. For all the guest OS, all of them are running on the OM. And how can they guarantee that when they're running the Linux or the Windows OS that it's going to run on the new KVM? It's based on the CPU hardware. It's going to control it, and what kind of access is going to involved. Every time before the command of the OS, then Yes, it's going to have a control called VMCS. In the VMCS, you are able to define its capturing behaviors. For example, what kind of sessions or what sessions on what kind of things that you want to capture. So this is implemented or performed by the hardware. Another question is that, and we have talked about the sequence virtualization, and maybe it has better performance than other virtualization, and also able to be aware by the OS. But it also needs some type of support. It means all of those Windows or the Linux need to support this type. First, for the first question, no matter is it the first type or the second type, the OS is not that the visibility of it is not that high. You can only see the interface. The second is that you find now the versions need to support both of those types. Before the OS are established, then it's going to build up a CPA ID, and then the VM is going to provide the CPA ID to it, and then it gets OS started, and you get the CPA ID, and then it's going to switch it to the KVM. If it's a sensitive interface like Zen, it's going to connect it with it as well and switch to it. And as for this virtualization, usually it's based on the same hardware structure, and then to plug it into our equipment. However, sometimes I want to run or mimic or run the ARM. The equipment, is it possible with the current structure? And I think it's just utilizing the hardware training is not enough. And then it's not able to support ARM. If you want to cross different CPU, maybe you need to use specific mimicking. Thank you very much.